All right, let's talk proportional relationships represented in tables. A proportional relationship, what does that even mean? Well, two quantities are proportional if there is a constant ratio between them. Now, that constant ratio could also be referred to as a consistent unit rate. It could also be referred to officially as the constant of proportionality. You should also know that proportional relationships can be set up as an equation, y equals k times x, where k is actually going to be the unit rate's number, also known as the constant of proportionality, and that unit rate will be multiplied to some variable. Here it's called generic x, but it can be any letter that you choose, and that's going to equal some other variable, any letter that you want it to be. Here it's called generic y. Let's put this all together. Here we have a table of values. We can see that it's hours, and we have the pay based on that number of hours. Is this a proportional relationship? Well, let's set up some fractions to find the unit rate. $50 divided by 2 hours would give us $25 per hour. But does that stay consistent? $75 divided by 3 hours, $25 per hour. What about $150 divided by 6? That's also $25 per hour. What about $275 divided by 11? That is also $25 per hour. So what does this mean? This is a proportional relationship because there is a constant ratio, also known as a consistent unit rate, also known as the constant of proportionality. And since we now have a constant ratio, a consistent unit rate, we can take the idea of per hour to set up an equation. 25 per hour means 25 times h for the hours. And what does that equal? Well, remember, that equaled our pay in dollars. So I picked the variable of P. And we could use this equation to actually get more values to extend our table. Now, if I'm going too fast for you, let me go back. Per hour means times the hours. You could actually take the 2 hours times 25. That would give you the $50. You could take 3 times 25, it would give you 75. You could take 6 times 25, that would give you 150. And yes, you could continue doing this for every single part of the table. So this is why I told you 25 per hour means 25 times the hours. That's where I get 25 times h from. And if my new amount of hours is 23, I can substitute that in. 25 times the 23 would give me $575 for the 23 hours. Let's look at another example. Now this one has the table set up a little bit differently. No big deal. We can still find out if this is a proportional relationship by dividing the quantities given to us in the table and seeing if there is a constant ratio. So 72 cents divided by 4 ounces will give me 18 cents per ounce. Does that ratio continue to be consistent? Well, let's go to the next quantities, 216 for 12 ounces. That divides to also give me 18 cents per ounce. What about 288 divided by 16? That is also 18 cents per ounce. And $5.04 divided by 28 also gives me 18 cents per ounce. So yes, this is a proportional relationship because there was a constant ratio between the two quantities, the dollars for the price and the ounces of the peanuts. Now, let's take it back to the equation. Since it's 18 cents per ounce, that means times to the ounces. So we are going to take 0.18 times a variable that will represent the ounces. Now, I didn't want to pick O because O looks too much like 0, so instead I picked N for the number of ounces, and that is going to equal the price of the peanuts, so I picked P for the price. Now, am I trying to tell you that every single table is going to be a proportional relationship? Of course not. This one, if you divide, you will not get a constant ratio at all. So this one would be a non-proportional relationship, and therefore I would not be able to write a simple equation like you saw me do in the previous two tables because there is no consistent unit rate.